Okay, so this is Pythagoras' theorem, and in these examples we are trying to find what is called the hypotenuse. Now in a right angled triangle, such as this one here, the hypotenuse is the name given to the largest side. So the largest side here is labelled C, that is called the hypotenuse. Now what Pythagoras realised was that if I was to draw a square off this side and work out its area, draw a square off this side and work out its area, then these two squares added together would equal the area of the square drawn from the hypotenuse. Now we're not going to draw squares, but we can easily work out that square's area, we can easily work out that square's area, and then we can add them together. Now this one we could do without a calculator, 5 squared being 25, 12 squared being 144, and we could add them together to give us 169. However, we have the calculator which we could equally use. Now that is not the value of C, that's the value of its area. So to find the value of C, what we must therefore do is square root 169. And if you know your times tables, the square root of 169 is 13, because 13 times 13 is 169. However, you can use the calculator. Most of these are on the calculator paper, and we've got the square root button up there. 169 equals, and 13 comes on the display. Second example, once again we require to work out the hypotenuse, so we use the previous method, Pythagoras' theorem. We work out that square, we work out the second square of the two smaller sides, and we add those two together. Now these are not numbers that you're expected to know the square of naturally, so we just use the calculator and we work out 17 squared button plus 24 square button equals, and the calculator gives us the answer 865. Now the value of D is not that quantity, that's the area of the square if I was to draw it off there. The value of D is the square root of that quantity, so we square root answer button equals, now it gives us it as a surd, i.e. the square root is still there. If you press the SD button, that's the standard format, decimal format, then we get our answer as 29.41088, and it carries on. However, with these kind of questions, we often round off to either 1, 2 decimal places. So if we was to round off to 2 decimal places, that means I would cut off after the 1 here, and because I'm cutting a 0 off, I would write down 29.41 as my answer. Now the triangles can be presented, instead of labelling the side, like I've labelled that as C and D in the previous two examples, instead we can label the angles on the triangle, and therefore that line would be called PQ, which is what we're asked to work out. So again, as with the previous two, we have been asked to work out the hypotenuse. So using Pythagoras' theorem, we'd have to work out 15 squared, we'd have to work out 21 squared, and then we would add those two areas together. So on the calculator, 15 squared plus 21 squared equals 666. And as I've repeatedly said in the last two, that is not the value of that side, it's the area of the square that can be drawn on that side. So this time I've labelled it as PQ, not just a single letter. So PQ, and to work it out we need to square root that value. So the square root of that number equals, again it's given us it in a surd format. If I press the SD button, I get 25.8069, and it carries on. Again, if I round this off, I'll go to 2 decimal places because the question actually says 2 decimal places. So 1, 2 decimal places, cut off. So it looks like it's 25.80. However, I'm cutting a 6 off, therefore I write that as a 1. So 25.81 is my answer.